Hello guys, welcome back. In this video we will cover the problem find out all the leaf nodes of a binary tree in both languages as usual, in Java and in Python. But in this video I'll start from the Python first and then implement the same in Java language. So let's begin. First we look what is a problem statement, and here is the problem statement. Find out all the leaf nodes of a binary tree in Python. So it will be a recursive implementation, okay, and here is our tree, and here is our desired output, right? So what exactly the leaf node is? First we have to understand what exactly the leaf node is. So leaf node is a node which have 0 childs, that is its left child is null or the right child, and the right child is null. For example, in the given tree, 1 has child 2 and 3, 2 has child 4, and 3 has child 5 and 6, and 5 has child 7 and 8. But notice the nodes 4, 7, 8 and 6. What is the common property in all these 4 nodes? The common is they don't have any child, that is their right subtree and the left subtree is null, right? So for this the output will be 4, 7, 8, 6. That is we have to print all the leaf nodes in the given binary tree, right? So let's discuss what is the leaf node. As I mentioned earlier, that a leaf node is a node that have 0 child nodes, right? Child nodes, that is its left and right child is null and none. In Python there is none, right? So let's begin. Hope you all understand with the concept of leaf nodes. So this is the basic Python template of tree data structure, right? This is the node class with its constructor. This is the method which we have to implement, find the leaf nodes, right? And this is the main which is used to initialize and calling the method, right? So without wasting any time, I'm just removing these lines and start writing our code. So first we have to apply the basic check which we have to apply in all the problems generated by the tree data structure. What is that? It is checking whether the root is null or not. Remember one thing, we have to apply this check in every recursive implementation of every code, right? So if root, again remember that in Python there is nothing like null, there is none. If root is equals to none, then return nothing. Else if root is not equals to none, it means it have some values, right? So now we have to check our next condition. What is that? We have to check the root which have its right child and left child none, right? So what we have to do, we have to check if root dot left is equals to what? None, and root dot right is equals to none. If it is true, that means the node is the leaf node, and we have to print this node dot data, right? And I'm using n for much readability, right? And this is it. if root dot left, let me run it fast. Oops, oh, I forget to traverse in both the left subtree and the right subtree. Let me quickly find leaf node, root dot left, and find leaf node, root dot right. So again run this code and hope, yes, we have achieved our output, that is 4786. So we have done the Python implementation. Let me revise for you that first we have to apply the check whether the root is none or not. If it is not none, then comes to a step, that is first check whether for a particular root its left child and the right child is none or not. If both the child are none, that means it is the leaf node and we have to print its data. After printing, we have to traverse in both the direction for further checking. So here we are recursively traversing left subtree, and this is for the same as right subtree, right? So this is for Python implementation. Now the time for Java implementation. So the same problem, recursive implementation. This is the tree, this is the desired output, that is 4, 7, 8 and 6 are the leaf nodes, right? So I hope you all aware of this question, what is leaf node. Let me quickly revise it for all you guys, that a leaf node is a node which have 0 child, that is its left child and the right child is null. Okay, so coming back to the null, because we are dealing right now with Java. So this is the node class along with its constructor, right? And this is the main class. Here we have a method which we have to implement, and here is the main method which is used to initialize the tree and calling the method. So let me remove this comment and write out the code. The same steps are to be followed. First we have to apply the check whether the root is null or not. If it is null, then return nothing. Otherwise, what we have to do, we have to check another. If it is not null, then root dot left is equals to null, and root dot right. If it is true, then it means it is a leaf node and we have to print it. Here we are done. Now the last two remaining step is traversing both the direction, right? So for this, find leaf node and root dot left, and find leaf node root dot right. So here we are done. Yes, this is it. Oops. Right. So let me quickly run it and waiting for the output. Yes, it is printing right. Oh, I have to specify the print method only instead of println, because println prints the output in every new line. So we are using just print method, and yes, we are getting the right output, desired output, and desired output is jet. So our function is achieved.